So Dr. Walensky has spoken to you about the exciting issues that we can now look forward to when you have vaccination. I'm going to talk to you a little bit about the future of where we want to go with vaccines with regard to coronaviruses, and that is the development of a universal coronavirus vaccine. If I could have the first slide. This is something that has been discussed now for some time. These two articles, one in the lay press in the New York Times from 𝐃𝐮𝐤𝐞, asking about the possibility of a universal coronavirus, and the other in Science magazine by John Cohen. So what would we mean by universal coronavirus? Next slide. This is the phylogenetic tree of the coronaviruses. The ones in red font are human coronaviruses, and the four that have yellow highlighting are the four viruses that account for anywhere from 5 to 15% of the common colds that we all get each year. Next slide. In 2002, you had SARS-CoV-1, and in 2012, you had the MERS coronavirus. Again, the first indication that coronaviruses were capable of pandemic potential. And then now, on the next slide, as you see, we are dealing with this very difficult situation of the historic pandemic of SARS-CoV-2. Next slide. So what people are asking is, can we actually conceptually and in reality get a pan-coronavirus vaccine? There have been a number of forays into that using different types of vaccine platforms. But there was a recent paper published that I want to spend just a minute on because it really is potentially exciting and it is an important proof of concept. Next slide. The paper appeared just a couple of days ago in the journal Nature. And what it is was the development of neutralizing antibodies for both pandemic and pre-emergent coronaviruses by a particular platform technology technique. Let me explain. Next slide. The proof of concept is one that antibodies that can neutralize multiple different coronaviruses have been isolated from people in their normal immune response who were infected with SARS-CoV-1. This was a strong suggestion that a pan-coronavirus might be possible. What the investigators at Duke University found out was that a specific highly conserved site on the receptor binding domain of the spike protein makes multiple human and bat coronaviruses highly vulnerable to cross-neutralizing antibodies. And with that observation, next slide, what they did is that they designed a nanoparticle vaccine, which actually displayed, as shown on this slide, 24 copies of this receptor binding domain and added an adjuvant to boost the immune response. And so in monkeys, the nanoparticle vaccine completely blocked SARS-CoV-2 infection and elicited higher neutralizing antibody activity than seen with current vaccines or with natural infection. But importantly, which is the crux of this discussion, is that the vaccine elicited cross-neutralizing antibody against bat coronaviruses, human SARS-CoV-1, SARS-CoV-2, and variants of SARS-CoV-2 that we are dealing with, such as B.1.1.7, P.1, and B.1.351. Now, although these are experiments conducted in a non-human primate, and we always have to have a caveat when you're dealing in a non-human primate, nonetheless, this is an extremely important proof of concept that we will be aggressively pursuing as we get into the development of human trials. So I'll stop there and back to you, Andy.